So, hello and welcome to the DV Digest. My name is Brody, and this is your monthly digest of insight from design verification leaders. Now, our next guest is a guy called Yogish Sekhar. Yogish has spent the last 20 years in verification, including positions of management, strategy, and business development. He has a multifaceted view of verification, having spent some time at Siemens on the vendor side, having spent some time at Imagination on strategy and analytics, and he also contributed to the core UVM 1.0 code base. More recently, he's been involved in educating engineers on how to involve machine learning in their chip design. So this is our second episode, mainly focused on AI verification. Yogish's background and what he's been focusing on recently more slants him towards the data analytics side. So we'll be talking a bit about what companies can do to prepare their data landscape. We'll be talking a bit about data security. And we'll also be talking more generally on how Yogish sees AI changing verification. I think it's a much needed conversation. I think it's super interesting, and yeah, I hope you enjoy.
So, Yogish, I think we should start by telling everybody a bit about your background. Where did you come from? Why have you got into engineering? And what's your career look like?
Firstly, thank you for having me, Brody. This is an amazing initiative that you've taken. Best of luck for this, and it's an honor for you to invite me as being one of your first few guests on the show. So best of luck, and let's go. So so where did I come from? So I bumbled into it. Let me be very honest. I never thought I would become an engineer in the first place. I always wanted to be a sportsman. I was good at it. I was doing platform diving at one point in my life for best part of 8, 9 years. Trained every day. And in one of my dives, I broke my back.
Oh, God's nightmare.
So you go, you train every day, you do a dive, get on a 10-meter platform, dive in, out, in, out. But in one of the dives on a one natural day, I just lost it in terms of the twist and the calculations that I was doing on fly. And I fell. And I was
never expected this, by the way, Yogish. This is the first I'm hearing this, and I'm blown back by this.
okay. So you fall into water at that way. If your finger, you don't break the surface tension with your finger, your body doesn't go in easy. And people must have done belly flops, and you feel the pain on the pool when you do a belly flop. But imagine hitting from a 10 meter, just falling flat on. It's like literally there. So that happened at one point in time, and after that, a fear of water set in, and my sports career just took a dive. And this was very young. I was very, very young, and I also had to figure out how to walk again because atrophy had set in on the muscles, and it kind of the pain was quite significant, and that meant my sports career took a beating because I was training for nationals and Commonwealth games to get into the team, make that happen.
Yeah.
Never happened.
Yeah.
So in India, if you don't become a sportsman, you end up becoming an engineer, a lawyer, or a doctor.
It's a pretty good fallback, to be fair.
Okay. So, and at that point in time, my dad was running a mechanical engineering company. Never wanted to work for him and spoil the relationship, what we already had. So chose to go into electronics and graduated, got into Intel as an apprentice and spent 2 years learning about ASIC design as an apprentice on a customer side of it. Then I was like, I really want to get into deep end of ASIC verification because that really interested me. So came to Edinburgh, did my master's over there, and then got into Broadcom, and then eventually set my roots here. Worked for some of the best companies like ARM, Imagination, Siemens. And then I'm now at an independent level where I'm looking to move forward, doing something different in the space.
Yeah. So it what was it like? What is that transition? Just kind of staying on this background a little bit. What was that transition like moving from a different country over to the UK? How did you find it? What are some things that you've learned in that transition? What's been surprising in that transition? That sort of thing. I know that you've obviously been here for ages now, but looking back at that time.
So transitioning to the UK, it was difficult. I was living in an environment where it was 25 degrees or above. Never, I mean, maximum I would have seen a drop in one winter about 14 degrees or something like that. I took a flight came in to about what, 4 degrees? Instant cold weather. And then eventually getting anglicized, literally. And and calling this place my home was massive amount. My kids grew up here. They're educated here. We lived here for 20 years, and getting involved in the society, getting involved in all aspects of British culture is where now I am at this point in time. So it's taken effort to blend in, make the shift, be involved in doing voluntary work for the Indian community here, and getting them involved in the community aspects. I've also taken up a role as becoming a parish councillor. So I'm involved in the local parish council, looking at day-to-day activities of the council and doing things. So that's what I'm doing at this point in time. So pretty well integrated, I would say.
Yeah, I don't doubt it at all. I don't doubt it at all. Okay, cool. So, I mean, the reason we're here, obviously, is to talk about AI and its role in verification. What do you expect the implementation of machine learning and large language models to do to the verification industry over the next, 3 to 5 years, and then onto the longer term,
Sure.
next 10 years?
Sure. Let's look at the flow that typically verification involves. You have a spec, which is driven by market analysis, market requirements, and then goes down into a technical architecture analysis, architecture requirements, and then you get into the spec mode. And then you define what are the core requirements of your design, be it at a SOC level, a subsystem level, or whatever. You start with that, and then you go into feature extraction, feature implementation. You then run coverage planning. You do debug regressions, and then eventually you have the feedback loop that does everything. The AI element comes in. Why it is important is the fact that there's a lot of data that is generated in the whole process. Okay, the data can be in form of running multiple regression runs on a day in and day out, and the need for compute to run that in regressions. It could be in debug. You generate a lot of debug text-based, log-based information, and to identify failure points and stuff like that. And it can also be right at the upfront in terms of how you're doing requirement analysis and even coverage planning and test bench creation. So there are many elements that we can break down. Let's take the front loading of the whole process, requirements analysis. Large language models now have shown how they can actually do deep dive analysis of your data set in terms of your textual documents, and how they can extract summaries, how they can extract information out in a very efficient way. A lot of the verification process hinged on the understanding of these specs by two independent people, one the design engineer and the other the verification engineer, who have to do the analysis independently, be able to extract out the necessary design elements of it and extract out the verification implications and the feature requirements of the design independently, and then speak to each other and go ahead. Large language models can spit them out very quickly or give you a first rough draft of both of these in a very succinct way, and then it can get your productivity going up. And if changes are seen because of some feedback bug or some feedback, it can actually go back and identify these requirement hits or requirement changes that could have an implication very quickly. So there are elements in this that can have significant uptake in what you call as low-hanging fruit, in terms of saying, here you go, here's my block level requirements, here's my system level requirements, here's my top level requirements. How does that fit back in? Can we make this better? And then you can also go in and say, okay, here's the block that has been designed with regards to, from the requirements, you analyze the interface specification. It can pull out the constraints. It can pull out a lot of the other test bench transaction capabilities. And then you can actually write and develop a skeleton infrastructure without the checking capabilities and stuff like those, and then run a basic simulation in a much quicker way. Earlier, during my time when I was younger and I was writing code on UVM and starting to develop the OVM, UVM models, there was a lot of learning that had to be just done. And sometimes it was a copy paste because you're copying code from one older test bench and putting it. All that can be automated. There's a lot of stuff that can be automated because the AI infrastructure, agentic AI pipelines such as the RAC pipelines can be taught to do this by extracting. If your specs are in an executable format, a lot of that information can pass through. Your infrastructure can be quickly put in place, and you can also look at changes that can have implications on test bench. Typically, some of these code changes may not be communicated cleanly, or the impact may not be communicated cleanly through the traditional pipelines. That can be automated in, and those elements can be pulled in quickly. We would have seen this yesterday in one of the vendors, this slide set, that they have access to the Git repository, they have access to the specs, and they have access to the plans. And the AI model that they are training up can actually say, looking at the plans and the changes in the plans, what implication and the Git repository might have, and what implication the test benches might have. So they are doing this already. So you will see one of the vendors coming.
Just as context for listeners, we were at a event yesterday where the vendors were, Synopsys, Siemens, and Cadence, all talking about AI in design and verification. Just as a bit of context there for the listeners. But yeah, sorry, go on, Yogish.
So we can see this happening. The vendors are training training up language models in order to make this happen. So this is the first impact of AI in the verification space that I can be confident that we will leverage elements of this within the design community and the verification community within the next 2 to 3 years, worst case. Let's take this one to the other extreme. Now, looking at data that is being generated by test benches and regressions, debug data and everything. There's a lot of unstructured data, regression logs, and everything that is generated and held within company firewalls. It has not made its way out into the open for good reason. And that data will be lost from project to project unless the company invests in a cohesive data strategy in order to move from a chaotic operation to an organized. From an organized, they go into optimized, and then from optimized, they go into efficient. So there's 4 ranges that you can do with the data strategy there. But this unstructured data will not, if that there's a lot of information in that data which usually doesn't make it out to get into an efficient mode. Big companies like Arm, Broadcom have massive teams of data scientists who look at operationalizing some of this information, pulling out efficiency metrics in order to budget their compute farm, investment decisions into emulation and prototyping, licensing needs with the vendors, and many of the other things that they may want, auxiliary functions they may want. But startups do not have that capability. They will not have that capability. So unless startups start thinking of their data strategy right from the beginning, they will not be able to monetize any of that information and be able to be smarter in getting AI to do any of the bits that they want. They may be able to throw data in and say, oh, why haven't we met our budgets? Why are we having challenges?
We'll cut that. Or maybe we won't. Who knows? Yeah, sorry.
It's more about understanding. So startups end up getting their seed investments. They have a very small, tight pot of money to do their product. And it's always like a Band-Aid. I have to get a feature out. I have to get a chip out with this kind of capabilities, and we just need rush in for doing the Band-Aid. Nobody thinks about putting a data strategy in place and having a understanding where the money is flowing.
Yeah.
And that has a big impact where AI can come in if you have a decent enough data strategy on the other side, where you're generating unstructured data through simulations, use of resources and debug information, and how much amount of time you're spending in each of these places. You can extract that information out, and you can and it can have a direct impact on the money that you spend and your bottom line, and controlling the bottom line.
All right. So what are some key things that you would be doing right now as, a small, medium-sized business to prepare your sort of data landscape for the next few years?
So elements of it are, I'm documenting all of these in the blogs that I'm doing as part of the data strategy, the platform analytics, and all these things. I'm putting it out there. So there's some information that is made public in this form, but there's a crucial element of data governance and data privacy and stuff like those that you need to hold dear right from the beginning in order to be able to make use of the AI technologies that is enhancing. Lang chains are going to come in eventually, and lang graphs are going to come in eventually, which will allow for predictive analytics to become mainstream. So with that in mind, synthetic data is now already being made available in some places to identify what parameters are key for companies in order to generate them and to be able to generate metrics and then correct those metrics to get your confidence intervals very sharp. You may understand what your spend point is, are you tracking towards your spend goal? Effectively, if you look at it going into the future, a lot of the semiconductor companies which use AWS or any of the cloud, Azure or Google Cloud for their infrastructure, as their infrastructure provider, will end up having to spend on compute on a sustained basis, and then also spike when they need to deliver their chips. And this bit of operational information typically is never thought through, because when they want to just get their chip out of the way, they will end up using an unthrottled compute, wherein they will just scale rapidly, and that can literally burn money in terms of their storage costs, their compute spot instances costs, and everything. And that bit of information will change. I mean, the information can be used to change the way they can move forward, slowly scaling it up in a linear fashion or in a step function by being able to predict their required capacity, and then what is the noise above that capacity as the scalable, what is it called? Fixed and unplanned capacity scaling. So there's elements of those that can come into play. And AI will definitely come in. Operational AI will come in, and many of the companies you can leverage some of this in something called an efficient frontier. Finance has already done this in terms of their risk and investment portfolios. The same efficient frontier concept can be brought in the operational space here, because you are having a risk of scaling and compute and not finishing the chips to the amount of money that you're investing in getting your compute platforms in play.
I think you mentioned at one point in passing data security. So I think this is an important point that obviously we've spoken about beforehand. And you know about, I mean, I think you reminded me of the Samsung leak that happened in 2023. What does this all kind of tell us about how managers should approach this data that they're gathering? And how does this also play into the landscape of EDA that we've got at the moment with these three big players, and what they can sort of do with their data, and whether we can, someone made a good point, didn't they, yesterday at this conference, about being locked into a certain vendor because of the data that you've built up with them in this individual LLM or SLM, you should say. So how should we approach our data management and our data privacy as we move forward?
Sure, let's talk about the Samsung case. So Samsung case was an interesting one because OpenAI had just come out a couple of months ago, and prior to this scenario happening, and Samsung engineers put their design IP onto the ChatGPT just to figure out where they were having challenges and stuff like that. And because it was put on, because of the terms and conditions of ChatGPT, you're putting the data in, it was allowing it for training, and hence the design became an open source, even though Samsung did not want it, and then they were not able to charge a royalty or even charge for that piece of design. Now, quite a lot has changed since that incident. Many of the companies, like, say, for example, Cadence, Siemens, and Synopsys, are having partnerships with the AI vendors like ChatGPT, Perplexity, Mistral, Anthropic. And they are getting it such a way that they want to create their own private language model. And these language models will become very domain specific. It's not going to be the large language model which knows literally everything. This will be focused very much on the semiconductor design and verification space. We will move to that, and each of the vendors will end up giving you potentially a language model that is very specific to their tool chains, their methodologies, and it will improve productivity. However, the flip side of it is that you are going to get invested within that ecosystem, similar to either an Android ecosystem or an Apple ecosystem, where you we are used to in terms of you having your friends or you having the best apps that you're thing. And once you have invested in an ecosystem, it's very difficult to switch. The switching costs are going to go through the roof because the retraining effort of those language models in a specific company will not it will not happen so easily because the model data cannot be transferred across from one language model that is trained to another language model that is with another vendor. So you could be held hostage. Let's not deny that. As the switching costs increase in this space, companies need to be careful in terms of how they are building their internal AI solutions with vendor-specific solutions. It can get you through in many spaces. It can improve your productivity, and it can also have an impact on your go-to-market strategy because it does so. But it's at an element of what value the company is creating to the value that the vendor is capturing. You got to be very clear about what is the willingness to pay for a specific product that you're creating to your customer, and how much of that is being taken away from you as a tax by the vendor. And that will play a huge role in the decision making. If you look at the current model, all vendors typically have good technologies in very specific regions. Say, for example, simulation, all of them are commoditized. Synopsys, Cadence, or Siemens are commoditized. But emulation, there's a big difference in terms of who you've already got. There is a lock-in in that space. If you built a flow which is very specific to Siemens, very specific to the Synopsys or on Exilium, you tend to use that flow for majority of your projects. But bigger companies have bigger purses, bigger budgets. They have flows that have been built which can shift across the three vendors because they've invested significantly with the vendors so that they are not held hostage. LLMs are the new hostage-making machines at this point in time.
I'll be clickbaiting that, as they say. Okay. Are there any other sort of concerns in terms of data privacy that you can think of? I mean, obviously, we were saying this before. There's a lot that we just don't know. There's a lot that we don't know how the landscape will look. Whether there'll be some, as was mentioned yesterday, some open source competitor to one of the EDA providers or the vendors. So there's a lot that we don't know. But is there anything else that the managers should be concerned about when we're talking about data privacy, especially in this sort of, I don't know, almost transitionary period?
I mean, be very careful of what you put onto the LLMs. Do not be stupid enough to put in your full source code on and expect it to not be taken away. Yes, it has immense productivity gains by using the LLMs, as we saw yesterday in the design conference. Couple companies are using it, but there needs to be guidelines and guardrails put in place in terms of governance of saying what can be done and what should not be done. And a lot of the new engineers, graduate engineers coming in who are using LLMs and doing their jobs explicitly need to be trained and shown how the tool can actually be useful and where it is useful and where it is not. Data privacy is crucial because your company secrets are kept behind company firewalls. And that is for a good reason, because you want to protect your IP. You want to make sure that it is monetizable, and you want to make money out of it. But if we have to talk about data governance, there's inward facing and outward facing. There's a bit of stuff that I'm researching on and documenting so that we can actually write a data governance policy on how AI can be used. So we need to understand, do we want to create a large language model which is very company specific, which is within the company infrastructure? I mean, if that is the case, then go ahead. You have taken an instance on OpenAI, ChatGPT, and you have licensed it from ChatGPT so that it can be within the firewall and you're able to do it. Go ahead and do what you have to do with that. But that comes down to corporate strategy.
At what point do you think it's necessary for companies to be employing head of data science, employing more data scientists? When in a company sort of life cycle, if you will, do you think that becomes necessary at this point? Should startups be thinking about this as the first 10 hires, or, when should people be thinking about this?
I mean, it comes down to the importance of what you're doing. Startups want to get their seed funding. Once they get their seed funding and they're trying to scale, they definitely need to start putting more importance to data and protecting all forms of data that is generated within the organization. Your operational data, if it is not protected, you're going to be bleeding money from unknown spaces, and you won't know until it is really, really late. Hiring a data scientist, it depends on what you really want to achieve. Big companies have big teams of data science, which is already being done. But small companies, small and medium-sized companies, they don't think about it until it is really late. And you are firefighting already, or your investors are pushing you to hire somebody. You won't. You are focused on your product. You are focused on delivery. But it is essential that you get some of this right from the beginning. At least the seeds of it from the CTO's office needs to be put in place. So anybody looking at it need to think through right from the beginning on how you look at data from the beginning. And because you have a clean sheet, and because you have a clean sheet, you should be striving to do this in an organized way.
So obviously, a lot of what we've spoken about here is potentially a bit concerning for engineers, especially those that are just starting out in their career. You can just think, a lot of what I'm going to be doing in the future is potentially going to be automated. What can people do to stay as relevant as possible for as long as possible? How do we keep up?
Learn to do the grunt work. That's where you do the learning when you're starting off. I'll give you an example here. I don't know if you've heard of this large language model specialization, which has been done in the law industry called Harvey. It has been named after Harvey Specter from Suits.
Really? Love that show.
Okay. So look at it this way. Harvey has raised $200 million from Sequoia Venture Capital Fund. And they are looking at getting into the big major law firms, which can literally pass the bar exam, and it can do the paralegals work today at this point in time. So how does it work in the law firm? Law firms hire graduates from law schools, then they are made to do drafts, go through line after line after line, and understand that, and that's how they grow into becoming junior partners and then grow into becoming partners in the law firm. Similar thing happens in our industry also. Good design and verification engineers who are now using the tools to generate code won't understand the implications of doing that code or debugging in wrong information. Things are going to get automated in such a way that you get spec that's going to generate your design and test bench and the RTL synthesis, and the layer of abstraction is going to keep going higher and higher. But that said, who cares about what's happening in the transistor level? That's moved on from the 1950s to being completely automated and very specific niche skills. People who look at it are very, very niche. They do it because they're really good at it or they're passionate about it. Similarly, verification skills are going to become like that. People who are going to do verification are going to become very niche, very passionate. You will end up becoming pigeonholed into a segment, and that'll end up, if you don't like that segment, traversing out means you go back, take a graduate role in some other place, and then move on or look at alternative pivoting careers and things like those. This is very much, unless you get to a space where you understand everything, you become an architect. You become so good at understanding customer requirements, the business side of it. You understand the technology and the implications and thing. You will and learn to be at that level. It will become difficult for generation coming in, and that's my personal view. And
I don't quite understand why do you think, just for me, I guess, because I'll be the only non-technical person listening to this. Why do you think that people are going to be pigeonholed? I don't quite understand the logic there. I'm not quite following.
I mean, look at it this way. If you're going into a certain area, you will go deep into that area to know the low-level details.
Okay. Yeah.
But if the AI will do a lot of these things, you got to learn to become the orchestrator of these things. And you need to know. But the thing is, the productivity will gain. There will be newer jobs. There will be newer elements of it that come in. You will need to understand wider regions of things. But if you go into a segment, you will end up being in that segment in a much deeper space, and that will happen. And that's my personal view. This is contrary to what the industry is saying at this point in time, but this is one view.
The guy at Cadence, I can't remember his name, basically was saying that, we don't deal with a lot of the lower level stuff now. We've taken a level of abstraction up, and AI is just going to allow us to take this another layer of abstraction above that, above actually coding, having everything in natural language. I guess that's what you mean by architecture. I guess that's what you mean. We'll just have people who are more generalist. Is that the sort of thing you're saying?
That is true.
Yeah,
I believe in that. But the fact is, as the AI becomes so intelligent that it is able to do many of the things when it comes into the architecture, when you become an architect, you need to understand all these segments quite deeply.
Yeah. I mean, so my thinking goes, at the minute, obviously AI is very good at these hyper specialized tasks, right? Tell it a thing to do and it's good at doing it. What it's not very good at doing is pulling lots of things from lots of different domains and thinking critically about how to bring them together, right?
That's a matter of time.
Is it though? So I think
so you look at it this way. What happened in the 1970s, 80s, and 90s was that the whole industry was doing netlists and schematics and everything. And eventually it took almost 30 years for it to get to a point where we are automating. It's a push button flow in terms of synthesis. It's a push button flow in terms of generating GDS and everything. But you still have people who are specialists who still verify the tools, what the tools are doing and everything. AI will automate that and make that far better. And once that happens, that knowledge is lost, because people will not be spending time looking at the details unless you go and be very much in the trenches of wanting to know that information.
Okay, I see what you're saying. And I agree. I think just my logic goes that obviously it's gonna happen eventually, where AI can effectively do everything that we can do but better. Taking information from all different sources and thinking critically about it. But that's not the sort of that's not the next, let's say, 5 years.
No, that's not in the next 5 years. Look at the development scale. It may be exponential. I don't know. I don't know what the next 3 years holds for us.
Yeah.
As a thing. But the only question I'm going to be asking is, are we walking into a dystopian future where AI does all the things and human just sits back and just enjoys the beer?
Yeah. All right. Yogesh, it's been an absolute pleasure. Thank you for coming on. And we'll see you next time.
See you. And best of luck, Brody. See you.
Thank you very much, mate. Cheers.